up? Welcome back to Brain Up, and today we are going to continue our chapter of acids, bases, and salts and finish it. This is the last video of acids, bases, and salts. So the last topic that we are left off with is about salts. Okay. So without any delay, let's get started. About salts. What is basically a salt? Salt is formed when neutralization reaction happens, right? So what are the uses of the salts in our day-to-day life? We are going to learn that. First of all, we are going to learn some characteristics of salts. Okay, salts of a strong acid and a strong base are neutral with pH value of 7. When you react a strong acid and a strong base in a neutralization reaction, you get a salt which is neutral. Okay, on the other hand, the salts of a strong acid and a weak base is acidic. Since the acid is dominating, uh, therefore the salt is said to be acidic and the pH is less than 7 of that salt. Similarly, when we react a weak acid and a strong base, we get a basic salt which is having a pH more than 7. So there are some chemicals that we use that are used in day-to-day life, which are taken out from common salt. You know what is common salt, right? Common salt is nothing but which you use in making food. Your mother puts salt in the food in order to enhance the taste of the recipe that she is making. So the salt formed from the reaction of hydrochloric acid and sodium hydroxide is called sodium chloride, which is nothing but common salt. This is the salt that you use in your food. Seawater contains many salts in it. Sodium is separated from these salts. So this salt, sodium chloride, is extracted from seawater, which is salty, and it is evaporated in the presence of sunlight, and we get uh, sodium chloride. But it is not completely pure. It contains impurities. Deposits of solid salts are also found in several parts of the world. We also sometimes get a solid form of a salt, which is a crystallized form of the salt. These large crystals are brown due to impurities. As I said, these salts contain some impurities like sand, rocks, pebbles, etc. So this is called rock salt. Okay, beds of rock salt were formed when seas of bygone ages dried up. So before the formation of land, this earth was completely a big single water body. So the rock salt was formed by the evaporation of this sea, and this as a result uh, uh, led to the formation of rock salt beds layers, which formed land. Rock salt is mined like coal. You know, coal. There are coal mines. Coal. In order to obtain coal, we are supposed to go into a coal mine and mine theirs. Similarly, rock salt also has several mines where you get this salt. Common salt is an important raw material for various materials of daily life. So from this common salt, further we can reproduce many other chemical raw materials, chemical compounds which are used extensively in day-to-day lives. If not in homes, in industries or elsewhere. So some of the materials that can be formed are sodium hydroxide, baking soda, washing soda, and bleaching powder, and many more other materials. So we are going to learn now what are the preparation methods of sodium hydroxide, baking soda, washing soda, and bleaching powder, and also we learn about their uses in day-to-day life. So the first one that we are going to look at is sodium hydroxide. So how is sodium hydroxide formed? There is a process called electrolysis. There is a big beaker in which two electrodes are kept, namely anode and cathode. They are connected by a wire to a battery, and in that beaker, a solution is added, which is sodium chloride solution here. Sodium chloride, as it is a common salt, we have to take its solution by adding water to the common salt. So this is also called as brine solution. So we are adding brine solution to the beaker, and electricity is passed through that beaker. Because of this passage of electricity, the sodium chloride dissociates into sodium anions, the sodium cations, and chloride anions. So all the sodium cations move to one side, and all the chloride anions move to the other side. Now there is another substance which is present, which is water. Water also dissociates and forms H plus cation and OH minus anion. Now at one side we are having uh, sodium and hydrogen cations, whereas we are having, on the other hand, we are having chlorine and chloride anion and hydroxide anion. So now what happens is that the sodium from the sodium chloride goes and gets attracted to the OH hydroxide ion and forms sodium hydroxide, whereas the hydrogen of water gets attracted to the chlorine in sodium chloride and forms hydrogen chloride, right? See here, sodium chloride reacts with water to give us sodium hydroxide plus chlorine. I have done a mistake here. Hydrogen doesn't react with chlorine. What really happens is that chlorine reacts with itself and forms chlorine molecules and liberates chlorine gas. Similarly, hydrogen also forms molecules of itself, and hydrogen gas is released. Both chlorine and hydrogen gases are released, whereas a precipitate NaOH, sodium hydroxide, settles down in the beaker. So this is how sodium hydroxide is formed. So these are the products that are formed after the reaction. At cathode we get hydrogen gas. At anode we get chlorine gas, and we get a precipitate which is sodium hydroxide. Now there are some other products that are formed from hydrogen gas alone, chlorine gas alone, and sodium hydroxide alone. And after the sorry, after the combination of hydrogen gas and chlorine gas, we get some other products. Now let's see what are those products. From hydrogen gas, we can use hydrogen gas as a fuel. We can mix it with ammonia to form fertilizers. We can use it in margarine. Similarly, when we take chlorine gas, we can use chlorine gas for the treatment of water. These are used in swimming pools, public swimming pools. These are used in PVC pipes, disinfectants, CFCs, which are the main reason for the depletion of ozone, and pesticides. Sodium hydroxide is used in degreasing of metals, the oily substance, right? In manufacturing of soaps and detergents, in making paper, and manufacturing of artificial fibers. When we combine hydrogen gas and chlorine gas, we get hydrochloric acid. So this hydrochloric acid is used for cleaning steel, for forming ammonium chloride, for in many medicine manufacturing and cosmetics manufacturing. When we combine chlorine gas and sodium hydroxide, we get bleach, which is used in laundries extensively. So now we are going to learn some byproducts. After this, the byproducts of the products that we got in the previous reaction. So the first one that we are going to learn is bleaching powder, CaOCl2. You have already come to know that chlorine gas is produced, right? At anode, chlorine gas is produced after the electrolysis of sodium chloride. This chlorine gas is used for the manufacturing of bleaching powder. Calcium hydroxide is reacted with this chlorine gas to give us CaOCl2, which is nothing but your bleaching powder and water. Bleaching powder is produced by the action of chlorine on slate lime, which is CaOH taken twice. Calcium hydroxide is also called as slate lime. Its chemical formula is CaOCl2. Now the uses of this bleaching powder are for bleaching cotton and linen in textile industry. It is used in textile industry for bleaching cotton and linen. It is used for bleaching wood pulp in paper factories. It is used in paper factories for the manufacturing of paper, and for bleaching washed clothes in laundry. It is also used in laundry on washed clothes. It is used as an oxidizing agent. It is rich in oxygen and lends oxygen to other compounds which are deficient of oxygen. So it is an oxidizing agent in many chemical. It is used as a oxidizing agent in many chemical industries, and it is also used for disinfecting drinking water to make it free of germs. Now let's move on and learn the second byproduct that we can get from the reaction, which is baking soda, NaHCO3. The soda commonly used in the kitchen for making tasty crispy pakoras is baking soda. The baking soda is used in the batter of your pakoras. Okay, these make the pakoras fluffy, and they are cooked faster with if we add baking soda to it. Otherwise it take somewhat longer time to get prepared. Sometimes it is added for faster cooking, as I said. The chemical name of the compound is sodium hydrogen carbonate. Sodium hydrogen carbonate ion. That's a sodium hydrogen carbonate. It is produced using sodium chloride, the brine solution, as one of the raw product materials. So this brine solution is reacted with water, carbon dioxide, and ammonia to give us ammonium chloride and your sodium hydrogen carbonate, which is baking soda. It is a mild, non-corrosive basic acid. It is mildly basic. So it is almost near to 7, but it's not 7. It is somewhere near 7. It can be 7.5, 7.6, anything. Something greater than 7. The following reaction takes place when it is heated during cooking. When you add this baking soda, when you are cooking food, the following reaction happens, and we get sodium carbonate, water, and carbon dioxide in return. So the uses of this baking soda are for making baking powder, which is a mixture of baking soda and a mild edible acid such as tartaric acid. So baking powder is prepared by adding a mild acid to the baking soda. So when baking powder is heated or mixed in water, the following reaction takes place. As we just now saw, sodium hydrogen carbonate reacts with heat to give us water and carbon dioxide with sodium carbonate. Here we are reacting with it with the acid as well. Okay, so after this reaction we get carbon dioxide, water, and sodium salt of acid. Carbon dioxide produced during this reaction causes bread or cake to rise, making them soft and spongy. It is extensively used in bakeries to make the cake fluffy. Okay, what is used? Baking powder is used, not baking soda. Sodium hydrogen carbonate is also an ingredient in antacids. We learned about antacids, so which help us getting rid of acidity to control the pH level of our stomach. So this sodium hydrogen carbonate is a part of that antacid. Being alkaline, it neutralizes excess acid in the stomach and provides relief. It is also used in soda acid fire extinguishers. It is also a component in the manufacture of fire extinguishers. So another compound that can be formed from that reaction is washing soda. Another chemical that can be obtained from sodium chloride, which is brine solution, is your washing soda, Na2CO3 dot 10H2O. We have seen above that sodium carbonate can be obtained by heating baking soda. This baking soda, sodium carbonate, this sodium carbonate is recrystallized and gives washing soda. It is also a basic salt. Okay, so this is the reaction of the manufacturing of washing soda. Sodium carbonate is reacted with water to give us sodium carbonate with water molecules, which is your washing soda. The water molecules, 10 water molecules here present in washing soda are together called as the water of crystallization. Okay, these are the reason why washing soda is the form of crystals. If we heat this washing soda, all the water molecules get lost and it becomes a white powder. Okay, it is defined as the water of crystallization is defined as the fixed number of water molecules present in one formula unit of a salt. Okay, this is one formula unit. This whole is a whole unit, is a single unit, which is called washing soda. One another salt that has water of crystallization is gypsum. Gypsum also contains these water molecules. Okay, its chemical formula is calcium sulf- uh, calcium sulfoxide with two molecules of water, CaSO4 dot 2H2O. It contains two water molecules. These are the water of crystallization in gypsum. Now, this gypsum is also used extensively for what? Let's find out. Plaster of Paris. You have heard this name. You are very familiar with this word, right? You might have used this in your art and craft if you are interested in art and craft. How this plaster of Paris is formed now? You just saw what is gypsum, CaSO4.2H2O. When you heat this gypsum at 373 Kelvin, the water is lost, right? After the losing of water, you get calcium sulfate hemihydride. We had two molecules of water before. Now, after heating this gypsum, we remain with half a molecule of water. CaSO4 dot half H2O. This is nothing but plaster of Paris. This is used to support fractured bones in the right position. When you experience a severe fracture, the doctor covers your fractured part with plaster of Paris so that the bone does not uh, move away from the position in which it is. Okay, plaster of Paris is a white powder, and on mixing with water it changes to gypsum backed, once again giving a hard solid mass. Calcium sulfate hemihydride, which is plaster of Paris, reacts with water to give us gypsum. So this is all for this chapter. We have completed the second chapter successfully. This is acids, bases and salts. Soon we'll start the third chapter. uh, okay, so if you like this video, please like, share and subscribe to my channel, and if you have any queries, doubts, please drop down in the comment box below. Thank you.